It ends in what? All binaries end in what?
Oh, it's aluminum sulfide.
Sulfide.
Yeah.
Aluminum sulfide. What do you think? Okay, now let's make our brain work a different way. Let's do some of these. What is the most likely compound to form between calcium and oxygen? Let's try that one. What's the most likely compound? Now here's how you do this. What's the charge of calcium always in a compound? He's in the +2, isn't he? So I write that down. Now, let's do the nonmetals. Nonmetals, these guys don't like to form compounds, so we're not going to talk about them. But this column here, what do they like to form? What kind of ions? It's not going to be plus. The metals like to do plus ions. -1. What about this column? -2. What about this column? -3. Can you remember that? Just write on your periodic table if you need to. All right, so what are you going to put for oxygen? Come on, this is easy. -2. Well, all compounds have a net charge of what? Well, does this have a net charge of 0? Then I think we're done. We're done. We actually wrote a real compound, and Hayden's going to help me out. Hayden, you know the name of this.
Calcium oxide.
See? Everybody get it? Let's do another one. What's the most likely compound to form between, let's see, how about magnesium and phosphorus? Ooh, that's a hard one. Okay, everybody try that. What's the most likely compound to form between magnesium and phosphorus? All right, now Taylor's going to help me, all right? Ready? Taylor, in a compound, what charge would, what kind of ion would magnesium form? Yes. But what about phosphorus? -3. All right, now, it's a little tricky because how are we going to get this to add up to 0? We can't. So what are we going to do here? How many? Okay, now the subscript tells you how many you're going to have, so it can't be plus or minus. It would just be a number, right? What's the smallest number that 2 and 3 both get to go into? Yeah, Taylor, what's the smallest number 2 and 3 both go into evenly? 6. So what times 3 is 6?
2.
And what times I'm sorry, my fault. What times 2 is 6? And what times 3 is 6?
2.
All right, let's take a look. If each phosphorus is -3 and you have 2 of them, then how many is that? -6. And what about each magnesium is +2 and you have 3 of those? Aha. You think we have a compound there? Does that add up to 0? All right, Taylor, what's the name of this compound?
Magnesium oxide.
Yes, yes, yes. Do you notice that the little subscripts down here, does anybody know what subscripts are? Sub, like submarine, below. Sub means written below, doesn't it? Script means to write. Subscript. What do you call exponents in math? What's another name for an exponent? Not subscript, but
Power.
super. No, that's called power. It is a power, yes. But it's also called a superscript, isn't it? Superscript, subscript.
No, I never heard of it.
You never heard of superscript? Okay, good. Now you learned something. Have you heard of subscript?
Yeah.
Okay. Now look down here. Notice that I didn't look at the subscripts to name it. And for type 1, you don't. All right. What do you think? Did you fill in some gaps from yesterday? Now, I'll give you a little clue in this chapter. You have to work at this. You have to work at it. If you just sit there, and I know it's the last period of the day, isn't it? You know that? I know that. Yeah, I know that. But you have to work at this. So now, I'm going to go to type 2. Here we go. What's type 2? Ooh. Wait a minute. That's the same. And what about, oh, that's the same. Wait a minute. It looks the same. What's the only difference between type 1 and type 2? What's it say here?
It's not at all.
Yeah, it's not an always metal. And you know what? There are a whole bunch. See this little guy here, little stair step? Everything here is a metal. Everything. And we only had a few that were always metals, right? So everything else is called not an always metal. Yes? Yeah. Now, can I show you how this works now? If you'll pay attention to this right here, you'll say, you know what? Type 2 is just like type 1, except I had to do a little bit more work. A little bit. All right, so let me show you something. All right, can everybody look at that? Now, let me, who did I never call on? Gabe, I never call you, okay? Gabe, tell me the name of this. Pretend like it's a type 1, and just tell me what you think the name would be here. Fe is iron.
Iron oxide.
All right, now, excellent. Now, what I'm going to do here, watch now. Leave a space here. Iron oxide. See, you're already halfway to knowing these. Now, Gabe, name this one now.
Iron to the second oxide.
No, act like it's a type 1. You don't even look at those little numbers.
Iron oxide.
Oh, all right. Do you see a problem, Gabe? If you're a chemist, do you see a problem?
I see it too.
If I say, hey, go get the iron oxide, what are you going to say?
I don't know what iron oxide is.
There are 2 of them.
Oh.
How are we going to make sure? How do I make sure you get the right one? So, if type 2, I didn't do this. God did this. See, God said, there's only one way you're going to be able to make barium oxide. There's only one way. So just call it barium oxide. But God said, for iron, I'm going to let iron make 2 kinds of iron oxide. I didn't do that. And so what we had to do, chemists had a problem here because I don't want 2 different chemicals called the same name. Now here's an easy fix. I'll show you how they did it. Are you ready? It takes a little extra work. What is the charge of oxygen in a compound? And everybody should tell me. I should be right up here at the periodic table. What is the charge of oxygen in a compound? -2. Now, all compounds have a net charge of what? 0. Well, if that's -2, then this iron must be what? Does that make sense to you? Now, here's how they fixed it. Here's how they fixed the problem. They said, whatever the charge on the metal is, make that a Roman numeral. And you put that in the name. Aha. So what's the name of this? Iron, whose charge is 2, iron 2 oxide. I'm looking at your faces. All right. All right, ready? Mallory, help me out on this one. What's the charge of oxygen in a compound? All right, and how many of these oxygens do you have? So 3 times -2 is what? What is it? All right. Now, if all the compounds have a net charge of 0, then this better be +6 over here, right? So here we go, a little math here. 2 times what equals +6? +3. Now, what does the charge on the metal become? What's the charge on each iron? +3. So that becomes the Roman numeral. All right, so look at this. Iron 2 oxide, iron 3 oxide. Now, this is where we take a little breather. You will never use a Roman numeral for type 1. Why not? What? Why would you never use a Roman numeral for type 1? like this right here. See this stuff here? What do you call that? This is type 1. Everybody, sodium? It would have been chlorine, but in a compound it's called chlor. Yes. Sodium chloride is table salt, isn't it? Isn't that right? Now, why didn't I use a Roman numeral for sodium chloride? And you know what? How many ways can you make sodium chloride? That's it. So chemists they're people. Hey, wait, there's only one way to make it. Why do I need a Roman numeral? But look over here. How many ways can you make iron oxide? 2. So I have to tell you which one it is. There's only one way to make these. So do you understand that what's the only difference between type 2 and type 1? I have to figure out the charge on the metal. All right. Are you with me or not? I know it's the last period day, but you got to stay with me. All right? If you grab a hold of it today, you're going to be in good shape tomorrow. Okay, let's try another one. Sorry. All right, see that? I happen to know that there are 2 compounds between copper and chlorine, all right? I need somebody to help me here. Anybody volunteer? Volunteer, say, you know what, not sure I know what I'm doing, so if you call on me, it'll help me. Anybody? Sean? Okay, Sean. Sean, Sean, look at the periodic table. In a compound, Sean, what's the charge on a chlorine? Look, find it. It's over here. It's a non-metal.
17.
Okay, now, wow, 17, that's a pretty big charge. Now, wait a minute, what you have to remember is, this whole column in a compound, what charge are they going to have in a compound? -1. Now, if you haven't written that already on your periodic table, you should. So these are -1. What's this one? -2. And what about this column? -3. So you got that? You got that? Okay, so, Sean, help me out. What's the charge of chlorine in a compound? Okay? Now, Sean, all compounds have a net charge. That means if you add up all the plus and minus of what? Hey, Sean. Okay. Now, if all compounds have a net charge of 0, and this is -1, then what is this copper's charge got to be? Let him do it, okay? Wait. Ready? If it has to add up to 0, are you good at math? You like math? Okay. If this is -1 and the whole thing has to be 0, then what does this guy have to be? All right. There we go. All right. Now, ready? Because he's not an always metal, Sean, I can't just call him copper chloride, because this one's also called copper chloride. Everybody see that? Now, Sean, how did they fix this problem? They have 2 chemicals that could be called copper chloride, and we're going to use Roman numerals, right? And what's the Roman numeral stand for? And I circled it on your handout sheet. What's this say? The Roman numeral stands for what? What's this say? See right here? What's this say? Did you circle yours? See, if I circle that, don't you think that might mean it's important? So what does the Roman numeral stand for? Say it, just read it.
The charge on a metal?
Yes. What is the charge on your metal? So you put a Roman numeral 1 here. Now, let's do another one, Sean. You're going to be really good on this one. Look at me. You're going to be really good. What's the charge of chlorine in a compound? Yes. Now, how many chlorines do you have? What's 2 times -1? All right, now the whole thing has to add up to 0, so what does this copper have to be? If that's -2, when you add the minuses and plus together, you're going to get 0. If this is -2, let's try it again. If each chlorine's -1, you have 2 of them. That's -2. -2 plus what equals 0? Okay. So what does the Roman numeral stand for again? On the, which one's the metal? Okay, so what's the charge on copper? So you put a 2 here. What do you think? Now, watching him do that, if you understood, you said, you know, oh, I see now. You know, I'm okay if you make mistakes. If you don't make mistakes, make them here. Don't wait till the quiz. Don't wait till the test. Make your mistakes in class. You get it? If I'm your coach in basketball and we do a give and go or something like that, and you don't know how to do that, make your mistakes in practice, not in the game. Nobody can have a whole game without making mistakes, though. Is that right? You try not to make mistakes. Is that right? Anyway, all right. So what I'd like you to do is we're going to try, let me see if I can find your homework here. Wait, no, you can't. Let's see. Let me see what page. Okay, let's find this page right here, okay? Now, what I'm going to do is I want you to find either a type 1 or a type 2. Find a type 1 or a type 2. Just raise your hand. You said, I see one, number, and then help me do it. All right, Ben, which one?
Number 1.
Okay, now, everybody look, it's important. We've only done type 1 and 2, right? And so far, they had to be binary. Look right here. 1 element, 2 elements, 3 elements. We don't know how to do those yet. So we can't do number 1 yet.
But you do number 2.
Yes? All right, do you think it's binary?
That has 2.
Right? Do you think it is an ionic compound? Is it a metal and a non-metal?
Oh, so it's not 4.
Wait, is it a metal and a non-metal?
Yeah, you said it has 3.
It does. It only has 2. It has this one and that one. So it is binary. Is it a metal and a non-metal, Ben? Is it a metal and a non-metal? No, Ben, you're doing it. No.
You're good.
Potassium is. What about chlorine? Is it a non-metal? Then it's ionic, isn't it? Now, isn't it always metal? Sure? Okay. All right. You want to tell everybody in class which ones the always metals are? First row? Okay. This is the group 1A. And what charge do they always have in a compound? Okay. What about this group? Okay. And what about this? All right. Very good. See that? So it is one of the always metals, isn't it? So now, what's the name? Excellent, excellent. Now, why did he end it in IDE? Why did he end it in IDE? All binary compounds end in IDE. All right, another volunteer. Yes. Okay, you're correct. Is it binary? Is it a metal and a non-metal?
Yes.
Is it an always metal?
No.
All right.
Yes.
Is it or not?
Yes.
Are you sure? Bet $100?
No.
I would.
Yeah.
Because lithium is in that first column, isn't it? All right, so now we don't have to worry about Roman numerals, do we? So give me the name.
Lithium bromide.
All right, now you sound like a chemistry student. I need everybody in here to sound like a chemistry student. All right, somebody else. Volunteering is the best way to learn. It's the best way to learn. Even if you're not sure, you raise your hand. All right, go, Matthew. 5, yes. Is it binary? Is it a metal and a non-metal? So it's an ionic compound. Is it an always metal? You sure?
Yeah, it
Is it?
Yeah.
Bet $100? I would too. So that means we don't have to worry about Roman numerals. What's the name?
Magnesium chloride.
Magnesium. Now I'm feeling a lot better than I did at the beginning of the period. At the beginning of the period, you scared me a little bit. But now everybody's catching on a little bit. Next. Now, some of you who catch on very quickly, you should be raising your hand because this is a little more difficult. Who wants to do one that's a little more difficult? All right, Ben. Is this binary, Ben?
Yeah.
Is it a metal and non-metal?
Nah.
Nah. You mean sodium? Nah.
Wait,
Oh,
which
Na. Just kidding. What is it?
I thought we were doing 17.
No, you're doing 6.
Oh, we didn't start.
What do you think? Is it binary?
Yeah, it's fine.
Is it ionic? Is it a metal, non-metal?
No, it ain't.
Why are you talking like that?
Hey, wait, everybody's got to listen. Is iron a metal?
Yeah.
Yes.
Wait.
Yeah, but it ain't an always metal.
All right, but it's a metal, and is chlorine a non-metal?
Yeah.
All right, so, but is it an always metal? You said no, so it must be type 2. So now we're going to do a little extra work. So give me the name, act like it is a type 1, and we're going to leave a space. All right, go, Ben.
Iron chloride.
All right, and we're going to leave a space here. And the reason we're leaving a space is because he's non-always metal. So, Ben, we got to do a little extra work. All right, help me out, Ben. In a compound, what's the charge of chlorine in a compound? Everybody focus.
Is it 8?
No, now you sound like Sean.
20, 26.
No, now you sound like Sean. Let's try again. Now, ready? One more time. For the nonmetals, look now. For the nonmetals, these like to form -1 ions. What's this one? -2. And what these? -3. Okay, now, ready? What's the charge of the chlorine in this compound?
1. I thought you said a iron.
I know, but -1, isn't it? Isn't it -1? Now, how many chlorines do you have? 3 times -1? -3. -3 plus what equals 0?
3.
Okay, so we have to do a little extra work. Did we find the charge on the metal?
No.
Ask Sean. Sean, what does the Roman numeral stand for?
Charges.
That's right. And what is the charge on the metal?
3.
Okay, so that becomes the Roman numeral, and so we put it right there. So what is this called? Iron 3 chloride. Iron whose charge is 3 chloride. All right, we can't do the next one. What's the next one we would be able to do?
14.
Raise your hand. Who would? All right, J3, which one do you do? 14? Yes. All right, go. It's a little harder one, but we can do it.
Iron oxide.
Now, he would be correct if it was an always metal, he would be finished. Since it's not an always metal, you got to do a little extra work, okay? What's the charge of oxygen in a compound? And don't say 28 or,
-2.
yes. All right, now, J3, how many oxygens do you have? 3 times -2 is what? -6. Now, this part's -6, so this has to be +6. 2 times what equals +6? 2 times what is +6? Times.
Oh.
2 times what? +3. Now, ask Sean. Sean, what does the Roman numeral stand for?
Charge of the metal.
What is the charge on the metal, J3?
3.
That becomes your Roman numeral. So it's iron what? Iron 3 oxide. Now we should be getting a little better, right? Are we getting a little better? What's the next one that you were able to do? This one is an exception. I don't want you to do that one. That's an exception. We're going to do, Rachel never talks, so I'm going to have Rachel do it. Rachel, ready? Well, she talks. She just doesn't, she just pays attention, but I want her to talk more. Rachel, is this a binary compound? So we're doing number 21. Is it a metal and a non-metal? Yes. Is it an always metal? No. So go ahead and give me the name as if it was an always metal. What would you say? And Ni is nickel, in case you don't. Wow, excellent. Now, did you leave a space? And you know why I'm leaving a space? Because he's not an always metal, so help me out. Rachel, in a compound, what is the charge on a bromine? Yes. Look at that, right to it, right to it. How many bromines do you have? And what's 3 times -1? Now, the whole thing has to be 0. So what is the charge on the nickel? You only have one of them. So what's the charge on each nickel? Yes. Now, Sean, what does the Roman numeral stand for?
Charge of the metal.
Okay, what is the charge on the metal, Rachel? Okay, so what are you going to put here? Yes, yes, yes. Nickel what? Nickel 3 bromide. Notice, wait, every year I teach this, some of you think it's nickel 3 because you see a 3 here. No, No. It's 3 because the charge on the nickel is what? Plus 3. All right. I think there's one more we can do. Okay. Who's not sure? And I want you to say, I'm not sure. That's why I'm raising my hand right now. I'm not 100% sure. That's why I'm raising my hand. All right. Since nobody raised their hand, that means all of you are sure. I can pick anybody I want, can't I? All right. Thank you. I'm going to help you now. All right. So ready? I don't know if you remember that AU is gold. All right. Go ahead.
It's gold, chloride.
All right. So we'll put gold, leave a space. And Luke, why am I leaving a space between gold and chloride?
Because it's not what's the word?
It's not an always metal, is it? So that means I have to do a little extra work. Ready? Luke, in a compound, what is chlorine's charge in a compound?
-1.
Yes. And how many chlorines do you have?
3.
What's 3 times -1?
-3.
Now, the whole thing has to be 0. If this is -3, then the gold must be what? All right. Sean, what does the Roman numeral stand for?
Charge of the metal.
Okay, now, ready, Luke? What is the charge on the metal?
3.
So that becomes the Roman numeral?
And gold, 3, chloride.
Yes. Now, I have to look at your faces because you have to tell me the truth with your eyes. You have to tell me what's going on. So you didn't want to raise your hand a while ago, and you should have, shouldn't you? Are you feeling better? That's what you have to do. You have to do this. Okay, now, right now, that's the only ones you can do. Oh, okay, wait a minute. What time is it? Okay, I got a little bit of time. I got about 4 minutes. Now, so that's what you want to do here. Now, I want to turn over now. By the way, I made a mistake when I photocopied this. Notice that this page and the next ones, they're identical. Since you don't have to do the odd questions, this is your homework for this chapter, right? I made a mistake of photocopying the same page twice. As a matter of fact, there's 2 of them that are photocopied twice. And so please don't go home and do this entire page and then do the exact same page again. Do you understand that? I know you're smart enough to figure that out. Now, we got to do one more thing before you leave. All right, here we go. We got about 3 minutes. All right, everybody look at me. Everybody look, wait. Everybody stop. Wait a minute. Oh, wait till everybody's quiet. Okay, now, your brain has to work both ways. So now what I'm going to do is this page right here, the ones you are able to do, I'll circle them. These are the ones that you can do from the lesson so far. Okay, that's all. So if we get these 3 done, we're going to be done for the day. All right, I need somebody to raise their hand and said, I'm not sure. As a matter of fact, this is something new. Not new, but it's a different way of your brain. Aiden, you're sitting there so quiet. I know you can do this for me, right? Aiden, I'm going to tell, what's the formula for this? What do you think? Ask Sean what this Roman numeral stands for.
Stands for the charge of the metal.
Okay, so what is the charge on this iron, Aiden?
2.
So I'm going to put a +2 here. Look, see? Is that the charge on the metal? Okay, now, oxide. What do you think the element is?
Oxygen.
Okay, what is the charge of oxygen in a compound?
-2.
Yes. Does these already add to 0?
Yeah.
Then we are finished. So how do you write the formula for iron 2 oxide?
Yeah.
There we go. Next. Can you not have your phone out? Okay. Now, ready? Let's have another person. We're almost done here. Somebody else who has not exactly 100%. All right, Hayden, you should do it. All right, Hayden, ready? What am I start out with? What am I write first?
Iron,
And what else?
charge,
What's the charge?
3,
+3, right?
plus 3.
Okay, and then what's the other element?
Oxygen,
Okay, what's the charge of oxygen in a compound?
-3.
Okay, is this it then? Am I done? You know why? Because all compounds have a net charge of 0.
0.
Now look up here. This is a tricky one because what's the smallest number that these both go into? 6. So what times 3 is 6? And so look what happens. 3 times negative 2 is negative 6. What's 2 times positive 3?
6.
And we have it. We are done.
Let's go ahead.
By the way, of the 2 kinds of iron oxide, one of them, the second one, is called rust. If you ever wondered what rust was, it's iron 3 oxide. All right, we have one more. Somebody who, a lot of you have done a great job participating so far, so I need one more. Thomas, can you help me out? Can you finish up the day? All right, ready? What do I write?
CA.
What's the other element?
CH. CH.
Well, Ca is calcium.
No,
C's carbon.
C squared.
Oh, no, wait a minute. The other element is what?
CF.
CF. Okay, I don't have a CF, but I do have a CF. That's Californium. But Cl. Okay, now, wait, everybody, wait. Now, Thomas, in a compound, what charge does calcium have? Look in the periodic table.
20.
Plus what?
20.
Okay, all right. Oh, wait, I got you. Now, 20 is the atomic number, right? But remember how we said in a compound, these are always plus 1 charge? And what's this? Plus 2. Remember that? So calcium is going to be plus 2. Now, what's chlorine? What's the charge of chlorine in a compound? Everybody in this column has what charge in a compound? Almost. Remember, you don't count these. Negative what? Negative 1. Okay, help me out, Thomas. These do not add up to 0. So what do I need to do? See, right now I have a calcium that's plus 2 and I have a chlorine that's minus 1. That does not add up to 0. But look right here, Thomas. What if I had another one of these? What if I had 2 of these? Would that add up to 0? With plus 2? So I need, how many chlorines do I need? How many chlorines? 2. What if each chlorine is minus 1? I had 2 of them. Wouldn't that be minus 2? Okay, now, can you practice this a little bit tonight? And then tomorrow we're going to do type 3. Okay, we'll do type 3 tomorrow. All right, thank you very much.